Welcome to the EROS User Experience webinar series, where we talk to staff at EROS to learn more about the data, tools, and services coming out of the USGS Earth Resources Observation and Science, or EROS Center. Today's webinar is on Landsat products and services from the USGS. I am your host, Danielle Golan, the Remote Sensing User Services Lead here at EROS in Sioux Falls, South Dakota. The time is currently 12 p.m. Central, so let's go ahead and get started. First, a few logistics. To ensure the best audio experience, all participants have been muted. If you have any questions during the webinar, please enter them into the chat and we will address those questions at the end of the webinar. Today's webinar is being recorded. The recording will be available on the USGS EROS website and the USGS YouTube channel a few days after the webinar. The presentation will also be available online after this webinar. At the start and end of the webinar, we will have a few polling questions. These polling questions are optional, but your answers help us to create a better user experience in the future. And these polling questions will be available via the forms feature on Teams. And the questions will also be added to the chat in the event that you're unable to answer the forms feature in Teams based on your organization setting. So please feel free to respond to those polling questions in the chat or via form, whichever one works best for you. You should be able to see those initial polling questions now. Today's webinar will consist of a geo-narrative presentation, followed up by a quick question and answer session. During today's webinar, we will have two speakers, both are Landsat technical specialists. Our first speaker will be Holly Wilson from the Landsat Science Communications team and the Landsat International Cooperations Network project. And our second speaker will be Taylor Hansen from the Landsat Science Communications team. Holly will begin today's webinar with an overview of the Landsat program, and then Taylor will dive into the different Landsat data products. Later, they will provide more information on the tools and services to access Landsat data. Once they finish their presentation, we will transition over to an optional set of final polling questions, and then we will move on to the Q&A portion of the webinar. We have several user services staff members and members of the Landsat team here at EROS on the line to help answer any questions you may have. Please feel free to add your questions or feedback throughout the webinar using the webinar chat, and we'll answer any questions or feedback we receive at the end of the webinar. We will try to answer all of your questions in the time allotted, but if we're unable or we run out of time, we'll be sure to follow up with you after. In the future, if there's a webinar topic you would like us to cover, please feel free to suggest that in the chat as well. And with that, it's my pleasure to introduce our first speaker, Holly Wilson. Take it away, Holly.
All right, thanks, Danielle. Let me just share my screen. And I also just want to point out that Taylor and I are in the room together, and so we'll both be speaking from my mic. So if it looks like I'm still talking, it might be Taylor as well. So to get started, we'll do a brief overview of the Landsat program. So back in the 1960s, NASA sought to explore beyond our planet and into outer space. And while they were doing this, the United States Geological Survey saw great potential in this exploration with regard to looking back and studying the Earth from a space-based perspective. Then in 1966, after several photographs were taken by astronauts, including the famous blue marble image here on the left, it really demonstrated the value of such imaging records. And so as a result, the concept of the Landsat program began. Not long after, the first Landsat satellite launched in 1972. And so since then, a little over 50 years ago, there have been 8 successful Landsat satellite launches, with Landsat 8 and 9 actively imaging the Earth. The Landsat series of satellites still continues to provide consistent and constant remotely sensed data for scientists and decision makers. And so you can see here on this graphic the duration of each Landsat satellites that they acquired data and from launch to decommissioning. So to sum it up, the Landsat program is a series of Earth observing satellite missions that are jointly managed by NASA and the United States Geological Survey. So NASA is responsible for developing the space and launch segments. They build, launch, and perform the on-orbit checkouts for the Landsat satellites. You can see some images here from when Landsat 8 was launched, and another image of the thermal instrument that is now on board Landsat 9 being built. And the USGS is responsible for developing the ground segment and operating the mission after launch. So USGS manages the network of satellite ground receiving stations, conducts mission operations, and processes and distributes the data acquired by the Landsat satellites. These images here are of the satellite ground network receiving stations that are located all over the world. You can see a map here of the Landsat ground network. And these stations are responsible for downlinking the satellite telemetry and the science and image data that feeds the USGS Landsat archive. As I mentioned, so currently Landsat 7, Landsat 8, and 9 are collecting Earth image data, and collectively they are adding over 1,500 scenes to the USGS Landsat archive each day. One note is that while Landsat 7 is still technically an active mission, it's in what is considered an extended science mission era at a lower orbit. So we consider Landsat 8 and 9 to be our active science imaging missions. So with that, I'll just go in brief overview of the Landsat 8 and 9 missions and kind of describe the characteristics. And I just want to make a note that Landsat 9 is a copy of Landsat 8 by design. So a lot of the information that will be given here applies to both, but there are some minor differences with the instruments on board Landsat 9 that I'll point out when they come up. So for orbit information, both Landsat 8 and 9 orbit the Earth in a sun-synchronous near-polar orbit at 98.2 degree inclination at an altitude of 705 kilometers above the Earth. Each satellite completes an orbit of the Earth roughly every 99 minutes, and the mean local crossing time on each pass is 10 a.m. plus or minus 15 minutes. This crossing time provides maximum illumination and minimum water vapor in scenes, and at this orbit, each spacecraft is collecting roughly 750 scenes a day. So this video snippet for temporal revisit was made for Landsat 8, but also applies to Landsat 9. Both satellites are on a 16-day repeat visit cycle, meaning that every 16 days, Landsat 8 or 9 are imaging the exact same spot on the Earth. And so when you take both spacecrafts into account, the 16-day repeat cycle gets cut down to an 8-day revisit time. The instruments are capturing data along a 185-kilometer swath with a swath overlap or side lap varying from 7% right at the equator to a maximum of approximately 85% at extreme latitudes. Both Landsat 8 capture data at a 30-meter resolution for multispectral bands, one 15-meter panchromatic band, and two thermal bands. So for comparison, you can see this image. See here we have a 30-meter Landsat pixel that is roughly the same size as a baseball diamond. The 15-meter panchromatic pixel extends to the pitcher's mound. And then the thermal data is captured at 100 meters and then resampled down to 30 meters. So both Landsat 8 and 9 carry two sensors on board, the operational land imager and the thermal infrared sensor, so OLI and TIRS. The OLI sensor captures 9 spectral bands in the visible, near-infrared, and shortwave infrared portions of the electromagnetic spectrum. The TIRS instrument measures thermal radiance emitted from the land surface in the 2 thermal infrared bands. One thing that I do want to point out here is that the instruments on board Landsat 9 are replicas of those on Landsat 8 with a few key improvements. And so the OLI instrument on Landsat 9 has a higher radiometric resolution at 14-bit quantization, and that's compared to Landsat 8's 12 bits. And so what this improvement does is it allows the sensor on Landsat 9 to detect some more subtle differences, especially over darker areas, such as water or dense forests. And then with the TIRS on Landsat 9, there are some improvements made with regards to instrument risk class and then the design to minimize stray light. Okay, for spectral characteristics, the OLI sensor, like I mentioned before, captures 9 spectral bands in the visible near-infrared and shortwave infrared portions of the electromagnetic spectrum. And so just to explain this graphic in case it's a little confusing to look at if you've never seen it before, here we have the wavelength and then each Landsat, what each wavelength the Landsat bands are capturing. So this top row right here is for Landsat 8 and 9. So we have the first 9 bands that OLI is capturing, and then the 2 tiers thermal bands. I think this is a really nice graphic, and if you're interested in seeing the Landsat band designations compared to Sentinel, we have a graphic similar to this one on the USGS website. You could just Google Landsat Sentinel spectral characteristics and the image should come up so you can see the band comparisons for those. We don't have time really to go over all of the spectral characteristics band by band right now, but we will distribute a link at the end to this presentation, and you can read through these spectral characteristics for each of the Landsat bands on the left-hand side. So that is it for a mission overview. Now just to touch quick on Landsat data processing. So back in 2016, the USGS did a major reorganization of the management and structure of the Landsat data archive into a tiered collection. So it's a Landsat collections. And this change in new structure helps ensure that Landsat data products provide a more consistent archive. And that consistency then helps users more easily identify the quality of the data, which in turn better enables data stacking and scene comparison over time. So the rationale for the collection structure, just for some context, prior to Landsat collections, Landsat data was processed based on the most current calibration parameters or the best updates available at the time, which was really great, but also meant that you could be working with 2 Landsat scenes that had different radiometric and geometric corrections applied to them. So this made it really cumbersome for data users to identify what corrections were applied and to what scenes to ensure that their data was consistently corrected. So with collections, all Landsat scenes are processed in a consistent radiometric and geometric manner, which enables you to more easily determine the provenance and quality of the data. Back in December of 2020, we had the release of Collection 2, which provided some major updates to the Landsat Collection 1 that was originally released in 2016. And so some of those updates include improvement to absolute geolocation accuracy of the global ground reference dataset that gets used during Landsat Level 1 processing. There were some updated global digital elevation modeling sources added, some calibration and validation updates, and then the global level 2 surface reflectance and surface temperature scene-based products were released. After Collection 2 was released back in 2020, the Collection 1 data remained available for a certain period of time to help users transition their workflows to using Collection 2, but as of now, Collection 1 is no longer available. That is it for the program overview. Taylor is now going to talk about the different Landsat products available from the USGS.
Thank you, Holly. Now let's talk about some of the products that Landsat offers. So the USGS generates, maintains, and archives a variety of Landsat-derived data that are available for use at no cost to you, which is pretty cool. So first, let's go over our Landsat Level 1 data products. These consist of calibrated scaled digital numbers, or DN, that represent the multispectral image data. Level 1 data is categorized into a tier-based structure, and the highest tier data are radiometrically calibrated and geometrically corrected using ground control points and a digital elevation model data to correct for relief displacement. Next, let's go into our Landsat Level 2 data products. They are generated from our Level 1 data, which we just went over. And our Level 2 products are atmospherically corrected. So first, let's look at our Level 2 surface reflectance data product. So this example you see here covers the Missouri River in South Dakota. On the left here, we have our basic Level 1 data product. And then on our right, we have our Level 2 surface reflectance. And as you can see, there is a major difference in how our Level 2 looks compared to Level 1. Our Level 2 looks a lot more clear, less clouded. And so our level 2 surface reflectance measures the fraction of incoming solar radiation that is reflected from the Earth's surface back to our Landsat sensor. And all level 2 products are available globally from 1982 to the present. Next, we have our level 2 surface temperature product. And on the left here, this is an example of what a level 2 surface temperature product would look like. This covers the Missouri River in South Dakota. And the surface temperature product is generated from the Landsat level 1 thermal infrared bands. And the Landsat surface temperature measures the Earth's surface temperature in Kelvin. And it can be really important for geophysical parameters in global energy balance studies and different kinds of modeling. So surface temperature data can be useful for monitoring crop and vegetation health and extreme heat events such as natural disasters. As an example, could be volcanic eruptions and wildfire. It can also be used to look at urban heat island effects. And this product is available globally from 1982 to the present. Next, still under our level 2 products, we have our surface reflectance derived spectral indices. So Landsat has multiple spectral indices, and these are different combinations of spectral reflectance values from multiple bands to highlight features of interest that you were looking for. So these indices are derived from our level 2 surface reflectance products. These indices can be obtained from our on-demand data portal, and we'll cover that a little bit later. And here is a list of the indices that we offer. They cover vegetation health, burned area, and snow cover. And all products are available globally from 1982 to the present. And these products can be really useful, again, for looking at burned areas, burn severity, post-fire recovery studies, vegetation density and plant health, and snow cover. Here's just an example of one of these indices. This is a relatively popular indice to be used. It's called the Normalized Difference Vegetation Index, or NDVI. And this is how we calculate it depending on the satellite and the sensor that we are using. And then lastly, in our level 2 products, we have our provisional aquatic reflectance. This here is an example of what it looks like. And this is over the North Carolina coast. The left is a level 1 image, and the right is our provisional aquatic product over the same area and the same scene. This product is derived from our Landsat 8 and 9 level 1 products over bodies of water. So this can be useful to aquatic sciences and environmental monitoring in coastal areas and inland waters. This is also an on-demand product. Next, let's take a look at our Landsat US Analysis Ready Data, or ARD. So this is different than our other products that I just went over because it is tile-based and is on a grid that is placed over the conterminous US, Alaska, and Hawaii, whereas the other products are scene-based on a path and row. This illustration here is an example of the grid system that we have for ARD. ARD products are processed into Alber's projected level 2 surface reflectance and temperature. So ARD products are available for the conterminous US, Alaska, Hawaii, from 1982 to the present. Each ARD tile is a bundle that includes top of atmosphere reflectance, surface reflectance and temperature, top of atmosphere brightness temperature, and pixel quality assessments. Now let's go into our level 3 science products. So these level 3 science products represent the biophysical properties on the Earth's surface, and all level 3 products are generated from the ARD inputs, which we just went over. Firstly, let's look at our level 3 burned area. Here's an example of 2 of the bands that this product offers. This is over the bootleg fire in Oregon in 2021. On the very left here is our ARD surface reflectance. The middle is the burned area classification. And then on the right is the burned probability band over the same area. Our burned area product identifies fire locations and burned areas. So this can be used to quantify fire trends and patterns, and then can be useful for fire evaluation and prediction. So this can be used for multiple communities. And as you can see in this table here are some communities, and let's choose one. So for climate research, the potential use of this product can be tracking the greenhouse gas generation and fire activity as an indicator or symptom of changes in climate. So again, the burned area includes two different raster layers, as we can see here, the burned classification and then the burn probability. And this is available for the conterminous United States and is acquired from 1984 to the present. Next, we have our dynamic surface water extent product, or as we call DSWE. In this example, that is over the Everglades National Park in Florida, we have our ARD surface reflectance image on the left and our DSWE interpreted band here on the right. So this classifies areas where water is not present and areas that have water present at different confidence intervals. So in this example, we see in gray that is indicated as not water, and then we have our confidence intervals here of water presence. So this can be really helpful and useful for wetland monitoring. And again, here are some communities that have some potential uses. So let's stick with climate sciences and change response. The potential use is energy balance, carbon cycling studies, and modeling. So the DSWE includes 6 different raster layers that determine the probability of certain factors in each pixel. So water presence, surface water conditions, and you can apply cloud and cloud shadow and snow cover information as well. This is available for the conterminous US, Alaska, and Hawaii from 1982 to the present. Next, we have our level 3 fractional snow covered area. This example here shows an ARD surface reflectance image on the left, and then on the right, we have our fractional snow cover product, and this is over Lake Tahoe. The fractional snow covered area provides a per pixel snow cover that indicates the percentage of a pixel covered by snow in a mountainous region or area. So each pixel is the percentage of snow that covers that pixel. So this can be really useful for snowpack analysis. And again, here's this nice little table we have of our communities. So Colorado State University can look at their Western US snowpack, and we can also use it for geospatial data providers. They can look at land cover and enhancement of their cartographic data. And so this is available for the northern and western areas of the conterminous United States and Alaska from 1982 to the present. We also have the fractional snow covered area statistics product. This provides an average snow cover percentage over different time intervals between 1984 and to the present. And as an example, we have a 5-year date range for this fractional snow cover statistic product. And then lastly, we have our provisional actual evapotranspiration, or EAT product. Here is an example over Palo Verde in California. On the left is a surface reflectance image, while the right is the ETA image over the same area. So ETA is different than our other level 3 science products because it is a scene-based product. And ETA, what does that do? Well, it measures the quantity of water that is removed from the surface from evaporation and transpiration. So this product is generated from surface energy balance model with our level 2 surface temperature product as the input. So this can be really useful to understand the spatiotemporal dynamics of water use over different ecosystems. And this product includes 4 different layers: actual ETA, ET fraction, ET uncertainty, and ET quality assessment. This is available for the conterminous United States from 1984 to the present. And since this is scene-based, this is an on-demand product. Now that we went over all of these really interesting and really useful products, how can we access them? Well, since 2008, Landsat level 1, 2, and 3 products are available for download at no cost to you. So first, Here's a very popular data portal for not just downloading Landsat data, but other data as well. Earth Explorer is a graphical interface used to define areas of interest by selecting an area on the map. So as you can see here, you can click and drop pins. You can drop one or multiple to cover an entire area. And then you can also decide what time interval you would like to look at data for. Landsat products that are available in this data portal is our level 1 scenes, our level 2 scenes, our Landsat US ARD tiles, and our level 3 tiled science products.
In addition to the traditional data download portal like Earth Explorer, all Landsat data is also available and accessible in the Amazon Web Services or AWS cloud platform. All of the data is in the Amazon Simple Storage Service or S3 requester pays bucket. And that bucket is located within the Oregon US West 2 region. So if you're interested in maybe getting started or learning how to access Landsat data more programmatically or within AWS, once you get this presentation, you can click on this Visit the Cloud Data Access page, and that will take you to the USGS Cloud Data Access page that will provide some more information about how to get started with accessing Landsat data in the cloud.
Then we have the EROS Science Processing Architecture, or ESPA. This is the on-demand interface that I was talking about. And so this is where you would submit a request to download science data products like the spectral indices, the provisional aquatic reflectance, and the provisional ETA. This portal allows for bulk ordering. You can also specify if you want to reproject or have some spatial subsetting, or if you would like to resize the pixels, you can also have that in there as well. And this also allows for multiple output formats. So you can use a GeoTIFF or you can download it in any other output that you would like to have your data in.
We also have some visualization tools that you can check out. We have GLOVIS, which is the Global Visualization Viewer, and this allows for on-the-fly viewing and download of some Landsat data. This is a data viewer that you can access, download some scenes, and there's more than just Landsat data in there. There's access to some limited data sets within the USGS archive that includes Landsat. And then there's also Landsat Look, which is obviously Landsat specific. And this tool allows online rapid viewing and access to USGS Collection 2 data. Landsat Look is a really neat tool. It leverages resources available via a commercial cloud environment, including cloud-optimized GeoTIFFs and spatiotemporal asset catalog metadata. In addition to data access, we're just going to go over some additional tools and services. We'll start off with the Landsat acquisition tool. So this tool provides an acquisition outlook for Landsat 8 and 9 for people who are interested in seeing what cycle day either spacecraft is on within their 16-day repeat visit cycle and what paths are part of that day. So this screenshot is actually for today for Landsat 9, so you can see the paths on this cycle day for Landsat 9. And then, so it's tabbed at the top, you can see on this screenshot. So if you click then on the tool on the pending acquisitions, you can actually get a scheduling outlook for to be acquired by either spacecraft. And so this will give you the actual scenes that are going to be acquired with their acquisition times. And so this is a really useful tool for determining when the next acquisition over your area of interest might be, or when the last few acquisitions over your area of interest were.
And then next here we have the quality assessment tool, or the QA toolbox. And this is designed to be used in ArcGIS Pro and ArcGIS Map. There are two tools within this toolbox, the extract QA tool and the decode QA tool. The decode tool does just that. It decodes bit-packed quality information for that scene. And it doesn't create any new layers, but it builds an attribute table that classifies each pixel with either cloud cover, cloud shadow, and other quality assessment bits. And this is actually an example of what the output would look like using the decode tool. This is an example over the Rocky Mountains in Colorado. And the light yellow are pixels with no cloud cover, and the light blue indicates pixels with cloud cover. And the darker yellow over here indicates and represents pixels with cloud shadow. Then the cyan color that you can kind of see here is snow, and then the brown is indicated as ice. Then we have the extract tool. It also does exactly just that. It extracts all the unique values and classifies them individually as defined by you. So you choose what bits and what quality assessments you want to specifically look at, and then it will output those individual layers for those pixels. So you can choose whatever ones you would like to see. Next, we have the spectral viewer, which allows you to evaluate up to 2 satellite sensors. And as you can see in this screenshot, this is an example. We're looking at Landsat 9, and so it shows you through the magnetic wavelengths. We can see where it's capturing and at what level it captures through the wavelengths. And then you can also choose up to 6 different target spectra. So if you're looking at something really specific, let's say you're looking at aspen green top, so you want to see what that looks like. And here we can see what a typical vegetation reflectance looks like, and we can see which bands. 1, 2, 3, we can see what bands here captures those reflectances. And then we can also compare it to, let's say, asphalt. So how does asphalt look compared to aspen green top vegetation? And how do those reflectances compare? And how does the Landsat 9 sensor possibly capture those target spectra?
So in addition to the more science-related tools we just talked about, we have some data discovery tools and tutorials you can check out. We'll start off with the STAC tutorial. First, briefly touch on what STAC is. So STAC, or Spatiotemporal Asset Catalog, is essentially a family of specifications that standardizes the way geospatial metadata is structured to help better enable data querying. And so the USGS utilizes STAC to better enable the search and discovery of Landsat data in the cloud by providing a STAC metadata record for every Landsat data product that's within the cloud. And so this tutorial, and again, when you get the link to it, you can click on the button right here to get to the STAC tutorial. But what this tutorial walks through basically is an introduction to STAC objects, the STAC specification and structure, through examples of querying the USGS Landsat data in the cloud using the Landsat STAC API. And then lastly, for data discovery, the Landsat archive dashboard on our website provides an interactive map view of what is in the USGS Landsat archive. So in a heat map-like format, you can see how many Landsat products there are for a given path row combination. You can see how many nighttime scenes there are on a separate map tab, and you can check out some stats on things like cumulative scenes within the archive. There's also some really cool filter options that you can filter for things like processing level. So if you're interested in seeing how many level 2 products are available for like a certain path row or for a certain area, or even looking at products by year, you can check out things like that.
That is the end of our webinar and our presentation. So I would just like to thank you all for coming to our webinar. And to stay up to date on Landsat, we have our Landsat news that you can get at our Landsat missions website. And then you can also subscribe to our newsletter, latest in Landsat, and you can also connect with us on social media. And if you have any questions, please feel free to reach out. Here is multiple ways that you can come and reach out to us. Thank you.
All right. Thank you for a great presentation, Holly and Taylor. For those of you on the webinar, I've added some final links into the chat with more information about Landsat, a link to this presentation, and more information about how to be signed up to be notified about the next webinar. At this time, we'll move on to the final polling questions that I mentioned earlier. So I'll send those in the polls. If you do have any additional questions that you didn't get a chance to ask, please start posting those in the chat as well now. And we'll take a few minutes to answer the polling questions, and then we will jump into answering those questions. And for those of you where your organization does not allow you to answer forms or see forms, I also did post the questions in the chat, so feel free to answer those in the chat as well. And it looks like we do have some responses coming in, so thank you to all of those of you that are posting those responses. If you do have any final questions, as I mentioned, or any feedback about Landsat or the USGS EROS web-based tools or that you saw today, perhaps new features you'd like to see in the future, either to the data or to the tools, please also feel free to add those in the chat. We will take one more minute and then we'll get started with our question and answer session. Yes, Cohen, feel free to answer the questions that I posted in the chat if you're not able to see the poll. All right, looks like we have most of our polling responses coming back in, so thank you all. If you're still working on that, feel free to continue. We'll leave those open for the rest of the webinar. But we did have one question that came in. Are on-demand requests for level 3 products only available in the United States and not other areas in the world?
I can take this one. The on-demand products from ESPA can be requested for Landsat scenes worldwide. However, our tiled level 3 products, so the burned area, our DSWE, and our fractional snow cover products are only available for the contiguous United States and Alaska and Hawaii. And that is because, as I had mentioned before, we use the ARD tiles to calculate and create those level 3 products.
Perfect. Thanks, Taylor. We had a second question that came in. Can Landsat see subterranean heat?
I can take that. So no, Landsat thermal bands measure skin temperature. We do have a specialist here. Saeed, if you would like to go in a little bit more, you can go ahead.
Yeah, I mean, you had the response there, Taylor. The answer is no. The thermal bands on board Landsat satellite missions, they measure emissive thermal infrared from the surface. So we do not do any subterranean heat measurements. I think maybe with the microwave remote sensing, we maybe have a better chance of measuring subterranean.
And the user did want to clarify, what about volcanic activity?
No, the answer is no for volcanic activity. I'm assuming they're talking about the subsurface volcanic activity.
Perfect. Thanks, Saeed. Are there any other questions in the chat? Looks like we still have a couple more polling question responses coming in. So thank you all for, again, answering those. It does look like that's all the questions that we have for today. Don't forget, if you have additional questions later about Landsat or any of the data, tools, or services available here at the USGS EROS, you can always email our team at that custserve@usgs.gov email I put in the chat. Thank you all for joining us again today. I will stick around for a few more minutes in case any other questions come in, but we want to thank you all for joining us, and we hope to see you at our next webinar in the future. If you'd like to be notified about our upcoming webinars, please feel free to sign up for that EROS user group by emailing that custserve@usgs.gov email address. But thank you again all for joining us today. And we'll stick around again just to see if there's any other questions. But thank you all for attending, and thanks for all the hand clapping we see and all the nice comments in the chat. Thank you all so much for attending.
Yeah, thank you, everyone.
Thanks.
For those of you that have just joined, the webinar has finished. We're just waiting around in case there's any additional questions and for users to be able to post their polling responses. The webinar was recorded. It will be available on the USGS YouTube page and on the Landsat page on the USGS EROS website. So we'll be able to send out that invitation link to view the video. And it looks like for my team, we do have additional question in the chat. Someone wrote, "Wonderful presentation. I'm interested in mapping changes in visible spectrum frequencies from lake surfaces. What Landsat coverage would you suggest?"
I can take this one. So I would probably suggest the DSWE product that I went over. You can also use the surface temperature product to look at the temperature of lakes, but it's just the surface. As Saeed had mentioned earlier, we can't capture any information that is below the surface of any lakes or bodies of water. So I would recommend the DSWE, and in turn also you can use the surface temperature.
Perfect. Thank you, Taylor. And we'll stick around a few more minutes since we have a couple more questions and polling responses. Someone did ask, the same user, are you saying DC?
I apologize. It's the dynamic surface water extent, or as we call DSWE.
Looks like we have another question. I'm also interested in mapping ice extent or duration on an inland lake. What coverage would you recommend for that?
That's a really good question. You could use DSWE or the dynamic surface water extent product as well, or you could use the provisional aquatic reflectance, which measures and provides the solar radiation reflected from beneath the water surface in the visible and near infrared spectral bands. You could also use the fractional snow cover product, so that shows not only snow, but it can show ice. And then in all quality assessment bands over any area, it does show pixels that are covered by ice. So you can also use that as well alongside those. You know, there's an array of products, but I would highly recommend the fractional snow cover area and take a look at that. But it is slightly limited to regions is the only thing.
We have a user that has asked, is the fractional snow cover data available in Michigan?
Yes, northern and western areas of the conterminous United States.
Perfect. Thank you, Taylor. And we had a question on if there was a link to accessing the snow cover data extent in the presentation.
There is not, but I'm going to send the product page on the USGS website link in the chat right now. And so this will have all of the product information as well as the coverage of that product.
Perfect. Thank you, Holly. We have about 5 minutes left of the hour, so if there's any other questions, please feel free to add them to the chat. We'll plan on sticking around a few more minutes. And again, thank you all for attending. We did have a question in the chat. If there's a set of tutorials for acquiring and applying Landsat data, do we offer anything like that?
That's a great question. We do have the stack tutorial, but that is a little extensive here. Besides that, as I believe that's the only tutorial that we have. Jacob, would you like to expand on that, or do you have anything else?
Yeah, I'll expand on that. So, David, I'm Jacob. I work with User Services. If you've got questions about Landsat, how to use it, how to access it, feel free to write in. We don't have a lot of just ready to go, this is the process for getting the data you're after. But if there's some project you're interested in, you can write into that custserve@usgs.gov email address. And you can put me in there, Jacob, or just write in and it'll probably find its way over to me. I can take the time, and if you've got a specific project you're after, kind of walk you through how you would set up an account, access the data. Can't do too much in regards to how you would work with it in like GIS software, but I can get you in a good place for kind of understanding what you would need to do to be able to get a final product you'd be invested in.
And that user has also asked, I'm using Google Earth Engine now that provides access to Landsat data and has a Java programming interface. Is that essentially what the Amazon Cloud Services provides?
I can take this one, and no, I'm going to say Google Earth Engine has kind of a programming interface, and so what we have in AWS is really just cloud storage. And so we have that AWS S3 bucket out there that you are able to go and access and pull data from. And so you do this programmatically. We really don't have like a programming interface available to do that.
And would that user still need to download the data?
It really kind of depends. You can go into, let's say, Earth Explorer and do your data access and download, or when you are accessing data in the cloud, there's kind of a few different ways that you can do it. You can certainly go pull the data from the cloud, or you can set up some sort of cloud environment yourself and access it right next to that S3 storage. It's a tough yes or no question because there's definitely multiple ways you can do it.
All right, it looks like we're just up at the end of the hour. I will post that email address again in the chat if anyone has any additional questions or would like to follow up with us about accessing, downloading, working with Landsat data. Again, Jacob's on the call. He's our user services staff member who will handle most of your Landsat questions. But with that, well, thank you again all for attending, and we're going to go ahead and end this webinar. But again, thank you everyone for attending.